All right, welcome. Algebra 2, shout out to you guys, all right? Hope you had a nice weekend. Let's go back into the game of math, and what we're learning about are complex numbers, right? So learning intention is students write complex numbers in the form a plus bi, where a and b are real numbers, and the imaginary unit I satisfies I squared equals minus 1. So if you're reading this, you're thinking, what on earth is this? What is all this blah blah? What is going on? Complex numbers, a plus bi, a unit that satisfies this. Don't worry about it yet. This will take 1 or 2 days to actually sink in. Okay? And so let's have the nice Cornell notes set up. We have our learning attention, essential question, the questions over here, and the do now for you guys. Okay? So pause the video, take your time, and write everything out here. So now let's say we're going back to the video. Let's read the essential question. It says, what properties do imaginary numbers hold? Okay, so remember, an imaginary number is this I. I is equal to square root of minus 1. And if I is equal to the square root of minus 1, then if we know this is true, right? What happens if we square this? This becomes I squared just becomes, well, what happens to the radical and the square? It cancels, so this is just minus 1. So I squared is equal to minus 1, and this will be very important for us, okay? So here, the game plan first is, how do we interact with I? Like, let's say if we were to add, subtract, and multiply imaginary numbers, what properties do they hold? Okay, what properties do they hold? So let's try and do the first question together. It says 3 plus 4i plus 7 minus 20i. Okay, so let me fix the camera angle a little bit. Okay, that's nice. So here, what we do here is 3 plus 4i. There's nothing we can do to combine them together. So here, this is basically just 3 plus 4i. You can't combine these two terms. It's not going to become 7i or something. And now here, what do? We have 7 minus 20i. We have to distribute that invisible 1, right? So if we distribute an invisible 1, then this just becomes plus 7 minus 20i. Okay? And now that we have this, combine like terms. So this is 3 plus 7 we can combine. So that's equal to 10. And 4i minus 20i, we can combine that to minus 16i. Okay? And now here, once we have this, the question is, can we simplify this more? And we can't. There's nothing more to simplify, because let's say you substitute, well, what is I equal to? I is equal to square root of negative 1. So if you were to just say that's equal to 10 minus 16 radical minus 1, it doesn't really accomplish anything. And remember, game plan is we want it as a complex number. And if we go back to that learning intention that seems a little confusing, let's go back to it. It says students write complex numbers in the form a plus bi. And here we have some a plus bi. It's not a plus, but it's a minus. And that's okay. So here it's 10 minus 16i. And here our a is equal to 10 and our b is equal to minus 16. So we can that's okay. And we want our complex numbers written like this. And remember, the 10 and the 16, these are real numbers. These a and b are real numbers. And what does it mean to be a real number? You have to be on the number line. Right? If you're on the number line, you're a real number. And I is that imaginary number. Okay? And I satisfies I squared equals minus 1, which we talked about over here. Okay? So this is just a feel for adding complex numbers. What about the next one? Here, we want to subtract complex numbers. Well, let's take a look at another example. Let's say I have that same example, right? What was it? 3 plus 4i minus 7 minus 20i. Right? And let's forget about this example for now. This is the example, right? Let's imagine that instead of an I, let's write an x. And we're used to the x, right? So minus 7 minus 20x. Imagine if we had this. Okay, let me put this away. Imagine we just had this, right? Forget about this for now. Imagine we had this and I said simplify for x. I just said simplify, right? So here, 3 plus 4x, we can't do anything. So this is 3 plus 4x. And remember, now here it says minus 7 minus 20x. And then what do you have to do here? Don't you remember, you have to distribute that minus 1 to both of them. So this becomes minus 7, and this becomes plus 20x, right? Minus 1 times the minus 20 is plus 20x. So now here, we have 3 minus 7, and that is, what is 3 minus 7? That is minus 4. And 4x plus 20x is plus 24x. And that's it. Well, the same thing is going to happen once we do this question here. Because look, 3 plus 4i, we can't do anything to it. Actually, let's just go back to this part here. If I were to do 3 plus 4i, you can't do anything. So that's just 3 plus 4i. And what do you do with this minus? We have to distribute the same, the same exact way. So here. And this becomes what? Minus 7 plus 20i, right? And now what happens here? This is 3 minus 7, which is minus 4, and 4i plus 20i is plus 24i. And that is it. We cannot simplify this anymore. It's the same way we tried to simplify here and we did it. And this is in what form? This is in the complex form. This is a complex number. It's an a plus bi. So that part is satisfied. So we're good with that. Okay? And now let's say if we wanted to here, we added, we subtracted. Let's say if we wanted to multiply, right? Let's look at this example. If I had 1 plus 2i and 1 minus 2i. Whoops, okay, camera angle is very bad. Okay, there we go. What if we wanted to multiply these two binomials, right? Well, let's forget about that one for now. Imagine if I just said, what is 1 plus 2x times 1 minus 2x, right? Imagine if I were to say, let's evaluate this. What do you have to do? You have to FOIL, right? This becomes what? 1 times 1 is 1. And the same thing is going to happen here. You're going to do 1 times 1, and that's 1. Well, what do you do here? If 1 times 1, then what's the next one? 1 minus 1 times the minus 2x, that's minus 2x. 2x times the positive 1, that's plus 2x. And 2x times minus 2x, this is minus 4x squared. Okay? And let's just follow the same thing here. Remember, 1 times 1 is 1. 1 times minus 2i is minus 2i. 2i times 1 is plus 2i. And 2i minus 2i is minus 4i squared. Okay? Seems very similar, right? Very similar. Well, let's see what happens. So here, 1 minus, well, here we can cancel these two, right? Minus 2x plus 2x, that just cancels. That's 0. And then what are you left with? 1 minus 4x squared. And once you see this, there's nothing more to simplify or factor. It is what it is. That's it. And the same thing will kind of happen here. But look at this. If minus 2i plus 2i cancels, and then what do you have? You have 1 minus 4i squared. And if you think that that's it, we're finished, well, remember, here, x squared can be anything, but I squared is equal to something. Remember, I squared is equal to minus 1. Okay? I squared is equal to minus 1. So 1 minus 4i squared, we can rewrite that as 1 minus 4. And look, the I squared is minus 1. So this becomes times a minus 1. And now what do you have? You have 1 minus 4 times minus 1 is plus 4. So that's just equal to 5. And then that's it. You see this simplified to this. But this we can't simplify anymore because I squared has a value and x squared, we never gave it a value. It's just some arbitrary kind of thing. Okie dokie. So hopefully this gave you a better idea that literally this is, imagine if an x was here, some variable, it's the same thing you're doing. So it's pretty straightforward. What I'd like you to do is, I'm going to give you some questions, some practice questions to solve. What I'd like you to do is have these down, right? Add these two binomials, multiply these two binomials, see what happens, get used to it, and we'll go over the questions together in the video. What I'd like you to do is try and do these questions by yourself, and then we'll go over them in class. Okie dokie, I'll see you.